Hello, everyone. My name is Jesus Fraga. I'm commercial sales engineer for the VRF product. And today I'm going to go through the quick start guide for the R32 products, specifically MultiPro. So first off, I'm going to show you guys how to get to the actual quick start guide. If you go to greecomfort.com, hover under products, you go down and you'll see a MultiPro R14A and a MultiPro R32. We know 14A is the old, R32 is the new. So we're going to go ahead and click on MultiPro R32. We'll see here it opens up the outdoor unit. You scroll down a little bit. We have our indoor unit selections. Keep scrolling. Then we'll see a taskbar here, and we're just going to go ahead and open it. Go ahead and click all. Once you click all, you'll see all the available documents for the outdoor unit, for the R32 outdoor unit. And so we have the service manual, the quick start guide, the parts manual, and all the submittals. So what we want to do today is do the quick start guide. MultiPro R32 quick start guide. Start off here. As we see, some things change and some things stay the same. So in MultiPro R32, we know that we have a communication data chain that goes to the indoor units. We still have our line voltage power. And to compare that to multi-zone mini splits, we know that multi-zone mini splits is 14.4 communication wire and power. So that means that this wire here has four conductors. One's used for communication, the other is used for ground, and the other two are for power. The main difference here is pretty much the communication method that is used. One will use the 14.4 as I stated, and another will use the 18.2 stranded communication wire. Now with R32 MultiPro, there's an added feature where you can actually power the indoor units via a terminal block at the outdoor unit. And we'll see that on the next page below. To clear some other information here on this page, we recommend that you have service disconnects at each indoor unit. Those units are going to be units that do not utilize heat kits. The reason for that is because the amperage that the heat kit will produce will not be capable of the wire that is supplied from the outdoor unit. There's an exception to this, and as I stated earlier, we'll see on the next page what I'm referencing to. The communication wire is 18.2 stranded wire. Does not have to be shielded, just stranded. And the indoor connected capacity requirement is the same as the 14A model. So you have to have a minimum of 50% and a maximum of 135. If you fall out of that window, the unit will not start and give you an error code. Depending on if you're low or if you're high, will be the error code that you see. So continuing on here to the next page, this is what I was talking about, the capability of the outdoor unit being able to actually power up the indoor units. And there's a lot of information here that you'll need to follow when you want to utilize this XT3 terminal block. This XT3 terminal block is the one that is going to carry the power to the indoor units. And if this is utilized, as we see here on the nameplate, you will have to follow the MOP for utilizing the outdoor terminal block XT3. So that is of 60 amps. As we see here, we got MOP, ODU only, 40 amps. And other devices means the indoor units, it's 60 amps. Emergency power is 15 amps. We will talk about emergency power later on in this quick start guide. So, as I had stated earlier, for the units that are utilizing heat kits, this will not be applicable to those units as the heat kits do pull more amperage. And the wire that is supplied from the outdoor unit to the indoor units, it will not be able to support that heat kit once it is engaged. So if any of the indoor units do have heat kits, as I stated, please utilize and please use a dedicated line of power from the panel. That way you don't run into any problems with inspectors. The emergency power MOP is 15 amps, MCA is 1, and it will only be used when required by local code. It is used to isolate the refrigerant in the outdoor unit when there is a power loss to the outdoor unit, or could be used with a fire alarm panel in a commercial application. So that was having to do with emergency power. It's not needed in every application, but The main time that you would use that is in pretty much in commercial. And we have supplied a wiring diagram here that is out of the service manual that explains exactly where those terminal blocks are sitting in the unit. And here's a reference photo of a GMV6 R32 3-ton unit. So the communication wire, nothing really changes on this side of it. We're still going to run our 18.2 from the outdoor unit. It's going to be D1 and D2 in the ground. So we know that we have D1 and D2 from the outdoor unit, goes to the first indoor unit. From the first indoor unit, goes to the second indoor unit, and so on and so forth. And the last unit in line is going to receive the quarter watt, 120 ohm resistor that comes with the outdoor unit. And so what you can do is you can place that across D1 and D2. That way you don't have any type of communication errors or communication faults when the system actually starts up. And so you'll notice this grounded wire here. We have a splice in the first unit, splice in the second unit, and we're going to go ahead and terminate at the last unit. Now, this doesn't mean that we're going to land these wires in the middle of the communication method. So splicing, we know we're going to grab the ground going to the next unit and the ground coming from the next unit and pretty much splice it together here, splice it together here, and only terminate at the last point of contact in that data chain. And so this gives one path of interference, if there ever is any, in this communication data chain. So that means if there's some type of communication fault here or a ground, it'll travel its way out to the outdoor unit and terminate there and not in between the data chain communication. So going on. So for auto addressing, it's a lot similar to the 410A models. The indoor units will auto address, randomly selecting the main indoor unit. Main indoor units can be changed, use the wired controller or wireless remote. So what this means is you can actually go into the wired controller, before you actually go through the commissioning and designate what address you want for what area. That way, if you're mapping out a site, you can do that with ease instead of it doing it randomly. But an added feature and something that I always mention is that it'll do it automatically. So there's no need to manually do this. You can do it for mapping out purposes, but it's not necessary. And so we go on here with the addressing again. So the setting of main indoor unit, as I stated, you can go to the wired controller that you choose to be the main indoor unit and actually designate that system for main indoor unit operation. What this means is this main indoor unit will be able to change, will be the only unit that will be able to change the mode from heating to cooling and vice versa. If you try to go to any other controller in the system, you will not be able to do that. You'll just get, actually, you won't even get the selection of the opposite mode that the unit is in the subordinate controllers. And so here's more information on how to do that. You set the mode to fan, set temperature 86 or 30 degrees Celsius, press up and down 3 times quickly. UC will display on the indoor unit. This sets the unit to be the main unit. This applies to wireless controllers. Moving on now to the control wiring. Our ductless systems, they come with a remote controller, but they do have the possibility and the option for controller to be connected to the system. This is via H1 and H2. For example, here we have a wall-mounted unit. We have D1 and D2, which is coming from an outdoor condenser. And we also have another set of pins here, H1 and H2, which we know that that's our wired controller. So we open up this case and we'll see this terminal block there next to the line voltage terminal block. Another key feature here is if you wanted to control multiple units using one wired controller, you can also do this via daisy chaining the thermostat terminal block H1 and H2 via indoor unit to indoor unit to indoor unit. Depending on how many indoor units you have and you want this wired controller to control is how long your daisy chain, excuse me. Please remember that the wired controllers are only capable of doing up to 16 indoor units via one controller. So just keep that in mind. So in our new R32 wall-mounted unit, a Molex plug was actually included by the factory for installation out in the field. Me being in technical service and technical support, I always got the question of how am I supposed to wire this Molex plug up? This is the before picture here. The factory has actually supplied a Molex plug that actually connects to here, and now you have access to be able to easily connect a wired controller via H1 and H2 via this harness. This is on wall-mounted units. So moving on to central control and coordination, wiring and address setup. As I stated earlier on the previous slides, a lot of this information stays the same, so same applies here. The note here is this only applies if there's more than one condenser that will have a central controller or has co-automation. So if we have, for instance, 16 systems in line here, addressing strategy is pretty simple. So as we see here, we know that this is always going to be this first system. So because all the dip switches are actually in the off position. And once we go to the next system, we flip the first, we flip the second, so on and so forth. And we'll see that in the chart that we have on the next page for you guys. A quick note here is make sure that G1 and G2 are wired in daisy chain between the outdoor units. Set the dip switches on outdoor units. This should be done before the startup. Even a central control or coordination is not being connected until a later date. If you try to do this after the fact, you will have addressing conflicts and all sorts of other issues, and the system will give you the error codes pertaining to that fault. Going on forward here, this is the chart that I was referencing. So we know that system 1 is going to have all the dip switches in the off position. System 2 will have dip switch 1 in the on position. System 3 will have dip switch 2. System 4, 1 and 2, and so on and so forth, depending on the unit that's in line in your daisy chain. So as a note, as I stated earlier, please do this before startup, even if central control or coordination is not being connected until later. This will save you a lot of headache whenever you do try to add those additional controls. All right, moving on. Refrigerant piping installation guidelines and descriptions. This heat pump has two pipes, liquid and a gas. Both must be insulated. System mode is set by the user to determine main indoor unit, or is selected randomly by the system if you do a automatic addressing. A lot of these same things apply, so we know that 20 inches must be maintained between elbows, headers, and Y branches. And here's an explanation or an example on how those Y branches are actually laid out. Moving on. Y brancher and header installation. This is very important when it comes to installation to avoid things like compressor failures, inadequate cooling, increased energy bills, energy consumption. These installations of the Y branches and the headers are crucial. So as we know, they're specifically designed for even distribution of refrigerant. Each kit includes one Y branch for gas and one Y branch for liquid. Simply use a tubing cutter for larger line sets. If installed horizontally, they must be level. If installed vertically, they must be plumb. FQ01AA is used for downstream capacities of less than 68,000 BTUs. FQ01BA is used for downstream capacities of more than 68,000 BTUs. So a good way to look at this is typically you'll see this FQ01AA used for all the MultiPRO single phase equipment. FQ01BA is used for mainly commercial. Typically that's where you'll see it in the commercial applications is when this will come into effect. So moving on to headers, they are specifically designed for even distribution of refrigerant and oil. Each kit includes one header for gas and one header for liquid. And same thing as the Y branches, simply use a tubing cutter for larger line sets. must be installed horizontally and they must be level. Liquid header is built with downward facing offset for installation next to gas header, as we illustrated here in this picture. So this is the L shape of the liquid line, and the gas will sit on top of it if you choose to install it that way. As long as they're horizontal, you don't have to necessarily do this, but you know that they are designed to fit right on top of one another. So we have the FQ14/H1, and we know that that one's our 4-port header. FQ18/H1, that's our 8-port header. Moving on here. This is our single zone piping limitations. So it gives us, this chart pretty much gives us the max length ODU to IDU, the max height ODU above IDU, max height ODU below IDU, and we know those values are 213, 164, and 131 feet. So one of the key differences between the 410A and the R32 is the line set connections at the outdoor unit. For the R32 MultiPRO unit, all the line set sizes are 3/8 by 5/8. That's 3/8 liquid, 5/8 gas. And if it's necessary, please reduce the piping size at the indoor unit. So below is an illustration of a 1-to-1 and how to centrally locate that unit. So our dual and multi-zone MultiPRO. So here goes some more values of maximum piping lengths for the MultiPRO R32. So we have a max length of ODU to Y branch. We know that's 98 feet. Max length IDU to Y branch or header is 50 feet. Max height ODU above IDU is 98 feet. And max height ODU below IDU is 98 feet. So below is a basic limitation. Actual limitations are far greater. Use MultiPRO System Builder, MultiPRO Selector, or see installation manuals for more details. That's what I always like to mention, that we actually have the software on our GREE commercial site. It's a VRF selector. You can actually download it. It's free. And you punch in your outdoor units, your indoor units, and your copper links, and it'll actually give you the if it actually accepts the design and the additional refrigerant charge as necessary for your application. So moving on here, dual and multi-zone MultiPRO. So as we stated earlier, these are the line set connections for the outdoor units. We know they're all 3/8, 5/8, so no confusion there. This changes from the 410A models as 5 through 12K stay 1/4 inch to 3/8 line set connections for the indoor units, where before 3/8 would take us up to or down to 9,000 BTUs, and it would change at 12,000 BTUs to 1/2 inch. So now we have 5 through 12 will be 1/4 to 3/8 gas and liquid, and 14 through 24 will be 1/4 half gas liquid. 30 to 60 is 3/8 5/8 gas and liquid. And so below is an example of a multi-zone with a header installation. It's important to really centrally locate this. That way you don't have any really far line set connections that are coming off of this header. So as we see here, they're all pretty much, they're close to the same, sizes, except for this one right here in the middle. But pretty much the basic concept is centrally locate that header. That way you have reduced piping to do whenever you're out in the field. So moving on here, these additional pieces, or dog legs as we like to call them, will allow you connection of a 5/8 pipe. So pretty much it's an extension of the service valves from the actual compressor service valves to the outside of the unit. So these will take you to the right-hand side, and it'll penetrate through the access hole and let you connect your line sets there. That way you're not having to use a ratchet bender or fittings to be able to get up there to the flared connections. These dog legs actually let you connect the dog legs at the service valves and come outside of the cabinet. That way you're not having to do any of the ratchet bending or fittings. And each outdoor unit comes with these, so they're from the factory. They're not anything additional. So moving on here, the R32 MultiPRO also has shipping brackets as the 410A. So be sure to open up the sound jacket that's on the compressor and actually take those out. That way you don't have any unnecessary vibration or wear and tear on that compressor via the mounting brackets. So moving on, the nitrogen pressure test. This is another one of those things that pretty much stays the same. So once the piping is complete, pressurize the system through both service valves. Start at 150 and hold for 3 minutes. Increase to 325 and hold for 5 minutes. Increase to 500 and hold for 1 hour. And here's a chart on how to do that. Duration, examples. The evacuation. So, you always use a micron gauge because how are you going to know how many microns you have pulled down with your vacuum if you don't have a micron gauge? You can connect your liquid and gas, perform a triple evacuation. It's always recommended. It always ensures that the system is dry, and it often is quicker once you do verify that you do the triple evacuation. So the first step is pull down to 4,000 microns, hold for 15 minutes, break with some dry nitrogen, hold for 20 minutes, pull down to 1,500 microns, hold for 20 minutes, break with 3 psi of dry nitrogen, hold for 20 minutes, then pull down to 500 microns and hold for an hour. If it does not rise above the 1,000 microns, you're good. So this is an example of additional refrigerant, and we've provided a couple different examples here for you, so you're able to decipher how to calculate the additional charge. And this applies to the GMV V36, the 48, and the 60. So, as I stated, there's a couple examples here that you can follow and ensure that you have the correct additional refrigerant whenever it comes to that point in the installation and startup process. The debug process, pretty much it's the same as the 410A. So we know that once we have the system piped together, pulled a vacuum, and we're ready to do the actual start. This is after we've released the charge, added any additional refrigerant if needed. We're going to go ahead and verify that the outdoor unit says AO along with the indoor unit and its wired controllers. So everything in the system from the outdoor unit to the indoor units should show an AO. Once that's verified, you're going to go ahead and go through the debug process. And as you reach each step, there's an explanation here as to what they mean. And if you get anything other than this, likely it's going to be an error code. That error code needs to be referenced back to the service manual to see exactly what that is, or on the back of the service panel, which will tell you what that error code means. Usually when you get an error code, it means that there's something that went on with the installation, whether it's communication wire, whether it's maybe power to the indoor units, and so on and so forth. So just depending on what kind of error code you're getting at the outdoor unit will indicate what is actually wrong with the system. And once all those errors are corrected, if you have any, you should be able to easily go through this debug process and have the system fully operational within 40 to 45 minutes. One of the other things that we like to mention is the cold weather startup, especially now that we're in October. This is very crucial for compressor and compressor life. In cold weather, the compressor must warm up before system startup. Connect power to the outdoor unit and follow the chart below. So before, we recommended an 8-hour warm-up period, but that's no longer necessary. We have actually, along with the factory, have come up with the actual values and actual duration of the compressor warm-up, depending on the temperature that it is in the area or the outside environment. So we know that anything above 50 degrees is going to be a 1-hour warm-up period. Anything between 32 and 50 is going to be a 2-hour. Anything between 14 and 32 is going to be a 4-hour. And anything below 14 is going to recommend that 8-hour warm-up period. This is to ensure, as I stated earlier, that compressor, last as long as possible. Failure to follow this will result into catastrophic compressor failures. Maybe not initially, but prematurely. You'll notice during debug, this, along with a couple of other steps, will actually stop and it will not continue unless you actually manually confirm whether the value that the control board is receiving is correct or not. So if we stop at debug 08 and UO, this means the compressor warm-up period. And if you have already followed these steps, you can go ahead and hit SW3 and it'll continue on its course to doing the debug. So continuing here, the ducted unit static pressure. Similar to the 410A, there are 9 static pressure settings in the wired controller. The units are default for 5, so make sure that you're taking your static pressure across the air handler and adjusting as needed. We recommend that the total static pressure be within 0.4 to 0.5 static inches of water column. Anything below or above that will need to be adjusted. So as long as you're within that 0.4 to 0.5, you're good. And here's an illustration on how to actually take the static pressure. As I said, you'll take it across the air handler, so in the return plenum, the supply side, and depending on what value you get is how you'll follow the static pressure settings. So as I stated earlier, here's an explanation on what a main unit explanation actually means. There's one wired controller that's going to be designated as the main indoor unit. We need to not confuse this with main indoor wired controller. So the main difference is each system that has a wired controller will be designated as a main wired controller, but there's only one main indoor unit. That main indoor unit is what controls the mode from heating to cooling. So if you go to a controller and you try to change mode from heating to cooling and it doesn't give you the option, we know that that's a subordinate controller. Moving along, the A2L refrigerant leak alarm reset. Below is the illustration on how to reset the A2L alarm if it ever trips. So what you're going to do is you're going to power on the indoor unit, select fan mode, set the temperature to 68 degrees Fahrenheit, and within 5 seconds of doing that, press the light button 5 times in a row. And we know that this will actually reset the refrigerant leak sensor. Below is how to reset it through the XE7C23H wired controller. It's a similar process. You just press menu and OK button, which is the same button, it's just the designation on the controller as you see below. So what you can do is press left or right keys to get to highlight set, then press menu /OK. Press up or down buttons to scroll to parameter settings. Highlight parameter settings, press and hold menu OK button for at least 5 seconds, and the project parameters will appear on the screen. Highlight project parameters and press menu OK. Use up and down arrows to scroll to page 5. Use up and down to highlight lock status of refrigerant leak sensor. Use the right /left arrows to change the number to 1 to 0. This will reset the sensor and is no longer detecting a refrigerant leakage. So that's how to reset. So pretty much you have to go through the parameter settings and actually physically change the locked status of the refrigerant leakage. So what that means is you have to go in and clear 1 to 0 to be able to do the reset of the refrigerant leak sensor. Okay, everyone. Well, that was a quick start guide for MultiPRO R32. And I really hope this file helps you, as it has a ton of information to help through installation, through commissioning, and through anything that pertains to the R32 MultiPRO product. Remember, at GREE, we're by your side.